In this problem, we're looking at the deceleration of a plane as it is in the process of crashing. The problem gives us information about a few of the variables about this deceleration. First off, we're told that the time interval of the crash, so the time interval of that deceleration, is 6.50 milliseconds, or alternatively written as 6.5 times 10 to the power of negative 3 seconds. We're told that the acceleration has a magnitude of 3,400 g. So that is 3,400 multiplied by g, the constant acceleration due to gravity. And naturally, since the airplane is in the process of crashing, decelerating, its final speed is going to be 0 meters per second, if we assume that it has come to a complete stop at the end of the crash. Additionally, since the acceleration is a deceleration, we can make our acceleration negative. So we can add a negative sign to the magnitude that was given to us in the problem. Now the problem is asking us to find the speed at the beginning of the interval, so just as the plane was beginning to crash. So if we assume that the deceleration is constant, a constant acceleration, then we can treat this like any other constant acceleration problem. We're going to pull out the kinematics equations and figure out which one of them we're going to want to use. I have written out the three main equations here. Now recall that when we solve problems like this, the key thing is to figure out which equation contains all the variables we have and the one unknown that we're trying to find. In the case of this problem, we're given the final speed, the time interval, and the acceleration, and we're looking for the initial velocity, the initial speed. Now all three of these equations have the initial speed, the v0 variable, so any of them, we can't rule out any of the equations from that information alone, but the second and third equations include a displacement variable, which is completely unrelated to this problem and what we're trying to find. So the best equation for us to use in this case is the first equation, the speed equation, v equals v0 plus at, because it has the three variables that we know, t, a, and v, and it has the variable we want to find, v0. So let's take this equation and algebraically rewrite it to solve for v0. So to do so, we want to get v0 on its own, so we'll just subtract from both sides of the equation at. And what we find is that v0 is equal to v minus at. So this is the equation we're going to want to use, so all we got to do is plug in the values that were given to us in the problem into this equation. The final speed, as we discussed earlier, is 0 meters per second, minus a, which is negative 3,400 g's, so that's negative 3,400, multiplied by the acceleration due to gravity, which typically has a value of 9.8 meters per second squared. And then we multiply this by the time, in seconds. So we multiply by 6.5 times 10 to the power of negative 3 seconds. If we put all this into a calculator, then we find an initial speed of about 216.6 meters per second. So according to the black box, the plane had a speed of about 216.6 meters per second just as it was beginning to crash. And that is our answer. That is it for this problem, and I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have any questions or requests, leave a comment down below, and I'll do my best to help you out as best I can. That's all for now, and I hope you all have a lovely day. Bye-bye.